Welcome to this lesson on Pascal's principle. In this video, we'll explore one of the most fundamental concepts in fluid mechanics, how pressure transmits through fluids. This principle forms the foundation for understanding hydraulic systems and countless applications we encounter in everyday life. Pascal's principle states that when pressure is applied to a confined fluid, that pressure is transmitted equally in all directions throughout the entire fluid. Imagine pressing down on water trapped in a sealed container. The pressure you apply doesn't just stay where you pushed. Instead, it spreads uniformly in every direction: upward, downward, left, and right. Every point in the fluid experiences the same increase in pressure. For Pascal's principle to work effectively, two key conditions must be met. First, the fluid must be confined, meaning it needs to be enclosed in a container with no way to escape. Second, the fluid should be incompressible. This is why the principle works best with liquids like water or oil, rather than gases. Liquids maintain constant volume under pressure, allowing them to transmit force efficiently without being compressed. We can express Pascal's principle mathematically. The change in pressure, delta P, equals the force F divided by the area A. This simple relationship shows that when we apply a force over a certain area, we create a pressure change. This pressure change is what gets transmitted throughout the confined fluid. Understanding this formula is crucial for calculating how hydraulic systems amplify force. Let's break down how pressure actually transmits through a fluid. First, when you apply force to one part of the fluid, you're pushing on the molecules at that location. Second, these molecules are in constant contact with their neighboring molecules, so they transmit the force to adjacent molecules. Third, this process continues throughout the entire fluid body, resulting in pressure spreading uniformly everywhere. It's like a chain reaction at the molecular level. Hydraulic systems use Pascal's principle to multiply force in a remarkable way. The relationship is force 1 divided by area 1 equals force 2 divided by area 2. This means a small force applied over a small area can produce a much larger force over a larger area. The pressure remains constant throughout the system, but because force equals pressure times area, increasing the area increases the force. This is how a small input force can lift heavy objects. Pascal's principle is everywhere in the real world. Hydraulic brakes in your car use this principle to multiply the force from your foot pedal to stop heavy vehicles. Car lifts in repair shops use it to raise entire automobiles with minimal effort. Heavy machinery like excavators and bulldozers rely on hydraulic systems for their powerful movements. Even aircraft use hydraulic systems to control flight surfaces and landing gear. All of these applications demonstrate the practical power of pressure transmission in fluids. Let's review the essential points. First, pressure applied to a confined fluid transmits equally in all directions throughout that fluid. Second, this principle requires the fluid to be confined and incompressible. Third, hydraulic systems exploit this principle to multiply force by using different-sized pistons. And finally, Pascal's principle is the foundation of countless mechanical systems that make modern life possible, from the brakes in your car to the construction equipment building our cities.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.